Hi, welcome to review of Unit 1, where we are going to do basic operations with integers. We're going to review the rules of integers and basic addition, subtraction, multiplication, and division basic operations. Let's start at the beginning with variables and equations. Here you see 30x. We know that 30 is called the coefficient of x. X is the variable. This is telling you 30 times x. Here I have 30x plus 4. That plus 4 is called the constant. A constant never changes. It will always be 4, whereas 30x changes depending upon what x is, our independent variable. As x changes, the value of 30x changes, but 4 is constant. It is always 4. Let's do some vocabulary. Equation. An equation must have an equal sign. An expression does not have an equal sign. There is no equal or greater than or less than sign. There's no sign at all. Inequality. An inequality uses arrows. Greater than an equal, less than an equal. Evaluate means solve, give the answer. Inverse, when I say use the inverse operation, I'm also referring to the opposite. Inverse is the mathematical term for opposite. Variable is a letter of the alphabet that represents a missing value. Some examples. I have x plus 4. These are expressions. If I have x plus 4 and I want to make it into an equation, I replace x here with 11. 11 plus 4 is 15. If you have a variable and they tell you the variable equals a value, you plug it in and you solve. I'm going rather quickly through these because it is just review. Here I have 3x plus 2y. I replace x with 8. I replace y with 10. And I solve my equation. In section 1-2, we talked about trigger words. When you're reading a word problem and you have to write an equation, you are looking for some very specific trigger words to help you. So if I'm looking for addition, I might be looking for add, sum, more than, all together, plus, in addition to. I don't know if you need me to read all these to you. I think you can see them and read them yourself. Subtraction, less than, subtract, minus, difference, multiplication, product, multiply. Now that word per, the word per can be deceiving because per can also mean division. So be careful. When you're reading a word problem, you need to understand which operation you're using. But let's also remember that multiplication and division are related to each other. They're inverse operations. Same way addition and subtraction are inverse operations. Let's look at absolute value. Absolute value uses these slanted bars. And if your digit is inside those bars, it means absolute value is the distance from 0. The answer is always positive. Think of a tape measurer. If you are measuring distance using a ruler or a tape measurer, your tape measure does not have negative numbers on it. How far away is -3 from 0? It is 3 spaces. Absolute value of -17 is +17. If, however, I put an inverse sign, which sure looks an awful lot like a subtraction sign, doesn't it? Sadly, math does become very confusing with that little subtraction sign / inverse sign. The inverse of the absolute value of -17. Well, the absolute value of -17 is +17, and the inverse of +17 is -17. Vocabulary. Additive inverse means when two numbers are added together, they equal 0. The additive inverse of 17 is negative 17, because when I add 17 plus a negative 17, I get 0. They are also called opposites. If I have an expression inside my absolute value bars, I need to solve that expression first before I get a final answer. 17 minus 21 is negative 4. Absolute value of negative 4, positive 4. Remember, our answers are positive unless there's an inverse sign in front of the absolute value bars. The absolute value itself is positive too, but then I create its inverse while I'm doing it. Absolute value is a positive, not an opposite. Many people will see a negative 2 and they'll say, oh, it's 2. But then when they see 2, they want to call it negative 2. That is not absolute value. Absolute value is not an opposite. Additive inverse is an opposite. Absolute value is not additive inverse. Obviously, a lot of students make this mistake, or I wouldn't be showing it to you so prominently. You can look on a number line, and I just want to review for a moment that on a number line, the value farthest to the left is the smallest number. Negative 6 is less than negative 2, just in case you forgot that. Let's look at our first operation, adding integers. Lots of rules. There's rules for all of the operations. So let's start with adding. If you have the same sign, you combine and use that sign. 2 positives make a positive, 2 negatives make a negative. But what if you have different signs? Here's where it gets complicated. You find the difference and use the sign of the largest digit. I'm telling you right now that the textbook makes it a little more complicated. They will tell you that you find the absolute value of each digit and then subtract those. Well, I find my way just a little bit easier, and for my class, this is the way we do it. So if you're not from my class and you're going, that's not right, I understand. I have eliminated the word absolute value. The difference between 7 and 2 is 5. 7 is a larger digit than 2, and 7 is positive, so my answer is positive. 12 plus negative 20. The difference between 12 and 20 is 8. 20 is a larger digit, and it's negative, so my final answer is negative. Here are some practice problems that I think you should pause the video, take a look at the problems. So go ahead and pause. Welcome back, and let's take a look at the answers. Be very careful. You can see whenever the larger digit is a negative, your answer, your solution will be a negative. Same sign, keep that sign. Different signs, you're going to have to determine which digit was larger. Let's take a look at subtracting integers. This is the most complicated one. Eventually, you're going to learn to do it in your head. You're going to make up your own shortcuts. But we need to start with what is the real rule. The first integer stays the same. So I take a look at 3 minus a negative 4. And what I see is that I carry the 3 down. First integer stays the same. The subtraction sign changes to addition. And the second integer becomes its opposite or additive inverse. Negative 4 becomes positive 4. Now my equation is 3 plus 4 equals 7. Let's try another one. My first integer stays the same. Subtraction changes to addition, and 4 becomes a negative 4. And now I use rules of addition. 3 plus a negative 4. Well, 4 is a larger digit. 3, the difference between 3 and 4 is 1. 4 is a larger digit. I use negative in my solution. Many of you will say, well, I know what 3 minus 4 is. 4 was bigger, so I know that I'm going into negatives. If the second integer is positive and larger, you know you're going to have a negative answer, but you might not be ready for that yet. So let's just stay with the steps for now. Also remember that when you get to your final equation and you see two negative signs together, part of the cleaning up process, two negatives make a positive. A positive and a negative next to each other creates a negative. You can take a look at a number line and you can start with your first integer. In this case, 3 minus 2 equals 1. 3 minus 2, which means go back 2, and I land at 1. 4 plus 1, I start at 4, I go forward 1, and I land at 5. No double signs when you use a number line. You can't have your double signs. It's not going to come out quite right. Double signs become part of the cleanup process, and you have to clean up your equation before you start on a number line. If you convert to addition, your solution is larger, and if you stay using subtraction, your solution obviously gets smaller. Here are some examples. So again, I'd like you to pause the screen and I'd like you to clean up your problems, try to solve them. Some of these are substitution, which I believe is on your quiz at the end of this. So substitute in, replace K with a 12, replace M with a negative 5. That doesn't mean you take away the subtraction sign. You have minus a negative 5, so be careful. Pause. Welcome back. The answers. I've cleaned up and I have solved. Again, feel free to pause the screen if you would like to see if you got these correct or not. I'm going to give you one more page of examples. I'm not going to give too many because I know most of you aren't even pausing this. Pause. Welcome back. Here are your answers. Okay, let's move on to multiplication and division. This I find the easiest, multiplication and division. In multiplication and division, if you have the same sign, whether it be two positives or two negatives, your answer is always positive, even if your two digits were negatives. If, however, you have different signs, one positive and one negative, then you automatically have a negative answer, regardless of which digit is negative. Here, the 14 is a larger digit than 2, but here, the 3 is not a larger digit, yet our answer is still negative. So you need to just memorize the rule. Same sign, always positive. Different signs, always negative. Here I have a couple of practice problems. 8 times negative 4, different signs, negative. Negative 54 divided by 9, different signs, negative answer. Two negatives, positive. Review. If you have two numbers next to each other with parentheses, that means multiplication. Even one digit outside of parentheses means multiplication. When there is no sign with a parentheses present, it means multiply. A quick review of the distributive property. Remember that the sign goes with the term, so negative 7 times 5 is negative 35. Negative 7 times negative 12, positive 84. Now I have a negative plus a positive. Different signs, find the difference, use the sign of the larger digit. Use order of operations, real important. You're not going to just multiply negative 7 times 5 and then subtract 12. You need to do what's in the parentheses first, then multiply. Remember your order of operations, whether you use please excuse my dear Aunt Sally, whatever you were taught in school, please use it. Let's look at the distributive property again. In this case, I have 10 plus 4 times 5 minus 8. Parentheses and or multiplication comes first. So whether you solve what's in the parentheses, as I do on the right, first, then multiply, you can do that. Or you could have used the distributive property. And I could have done a 4 times 5 is positive 20, 4 times negative 8, negative 32, made a long string. Whichever you find easier, whether you use distributive property or order of operations, you will find that as the year goes on, we're going to use distributive property a lot. So it's good to have experience. But when you have a problem this simple, it's also easier to just solve what's in the parentheses first. Let's take a look at some examples. So I suggest that you pause the screen. Do the best you can. So pause. Welcome back. Let's take a look at the answers. There you have them. I'd pause the screen again. I don't want to waste video time, so pause the screen. I'll show you one more list. These here, I just circled some. Just in my class, we needed to move faster. So you do as many as you can. Pause. Answers. My last thing that I'd like to do, although I was also asked to please start giving a little shout out to some of my students who attend my weekly chats. So on day 1, I'm going with group 1 and saying hello to Angel. Angel, I hope you're watching this video so that you did hear my little shout out to you. The rest of my students, get ready. You'll get your shout out on lesson 2 and lesson 3 of this week. The last thing I want to show you, which is very filling on the screen, are the rules of integers. I suggest you pause it. I truly suggest you copy it because you need to have this handy at all times. I've given you the rules of addition, subtraction, multiplication, and division. I've talked a little bit about cleaning up equations with double signs, combining like terms we haven't talked about yet, but this is a review, so you do know what I'm talking about. Distributive property, inequalities. We just finished doing inequalities during remote learning. They're the same as equalities unless you multiply or divide by a negative value, you flip the sign. And if you flip the variable to the other side, you flip the sign. I hope you enjoyed basic rules of integers. I'll see you back again real soon for 1- and 2-step equations. Thank you.